This year alone, 42 children died in hot cars.
According to the CDC, children who are left unattended in parked cars are at greatest risk for heat stroke and even death.
2 children have died across Florida being left in hot cars.
A child was found locked inside a hot car.
Investigation of a child left in a car.
At just 9 months old, he died Friday in what law enforcement calls a preventable tragedy.
A preventable tragedy. Something so easy to fix. With technology, we can change the future. Introducing Seat Sentinel.
Hi, my name is William Klein, and I'm the project manager for the Seat Sentinel, a next-generation tech initiative. Just to give you some background, a CNN headline last year reported that more than 36 kids die in hot cars each year. These children die of heat stroke because their parents leave them in their car and they're unable to be rescued. So we asked ourselves as a team, how can we remind parents to come get their children, alert bystanders if they don't, and contact emergency services if the child's life is in jeopardy? And as a team, our answer to this question was the Seat Sentinel, helping parents keep their children safe. Just to give you a brief rundown of the solution, the Seat Sentinel is a smart car seat that implements the Internet of Things and dynamically analyzes the presence of a child in a car seat and makes calculated decisions to save that child's life if that child's life is in danger. The Seat Sentinel pushes a reminder to the parent's phone to come get their child. It sets off the car alarm to alert bystanders if the parent doesn't come, and it calls emergency services if necessary. Just to give you a brief overview of our market, our target market includes parents of children under the age of 6, parents of children who would require a car seat. We intend to begin selling online before expanding into retail, and while our competition includes all car seat manufacturers, we're unique in the fact that we're a smart car seat, and we intend to protect this intellectual property with the provisional utility patent we filed. We wanted to get a better idea of what our target market wants, so we conducted a survey outside of a local target. In conducting this survey, we asked everyone who appeared to be a parent to take our survey. We collected 20 surveys using a simple random sample of the target population. 8 of those surveys were parents of children under the age of 6, 7 were parents of 2, and 5 were parents of 3 or more. So we believe that our target audience in this survey is a good cross-section of the population as a whole. Now to briefly summarize our survey results. Parents tended to show significant concern that their children would suffer heat stroke from being left in a hot car, and they were equally afraid that they would leave their children in a hot car as they were that others would. They also tended to agree that this issue has become more serious recently, and they agreed that leaving a child in a hot car can be life-threatening. That said, parents were less likely to describe this issue as an epidemic. Moving on, parents were also not completely concerned that the Seat Sentinel, if hacked, would reveal their child's location, but they did believe that cybersecurity should be made a priority. Parents also overwhelmingly believed that crash protection is an important measure in any car seat, including the Seat Sentinel, and perhaps even more important than preventing child heat stroke. Parents did say that they would be more likely to purchase a car that supported our car seat, and they agreed that if a child's life is in jeopardy, drastic measures should be taken. We also asked parents about what they thought about the cost of a Seat Sentinel. For a flat fee, parents believed that they should pay anywhere between $50 and $75 more for the Seat Sentinel over a conventional car seat, and they were willing to pay around $5 a month for the LTE service the Seat Sentinel requires. Using these survey results, we came up with a 3-pronged marketing plan. First, we believe that we should emphasize the danger of child heat stroke and the need for a solution to our target market. We also want to emphasize the crash protection measures of the Seat Sentinel and emphasize the fact that the Seat Sentinel will take all measures necessary to save the child's life if the child's life is in danger. Finally, we want to charge $175 for the Seat Sentinel, as we believe that based on what the parents were willing to pay above a normal car seat price, that this will allow us to get our product out to the largest number of people. And we'll charge $5 a month for LTE service. We also want to sign a short-term exclusivity agreement with an auto manufacturer so we can have cooperative marketing. Now I'd like to introduce our software developer for the Seat Sentinel, Nathan Hamilton, to discuss UI design.
Thank you, William. With the design of the mobile application, we have a front end and a back end. And the front end is extensible markup language, which is XML. And this actually interacts with the mobile application to serve data to the user. With the serving of the data, we can show the user the location and the temperature of their car so they can make sure their child is safe and follow all precautions necessary. Here is a screenshot of our mobile application. On the left, this is our terms of service, and on the right we have a blueprint of our design, which shows the constraints in the dot per inch of the actual mobile application. Now I'd like to discuss the backend design. And the backend design uses Python and Java, and it uses Python to interact with the sensors and retrieve the data. This data is then sent to a server, which is then sent to the mobile application and shown using Java code. This Java code interacts with the UI front end to serve the data to the mobile user and to push notifications to emergency services or to the car. I would also like to discuss some use cases. And we have 3 different use cases, depending on the temperature of the car. In the first use case, we would alert the parent once the temperature of the car reaches 85 degrees Fahrenheit. In the second use case, we would alert bystanders through the data port in the car. This would set off the car alarm.
Thank you, Nathan. We plan to test launch our product in Pinellas County. As Pinellas County recently released 911 texting support, the Seat Sentinel will take advantage of this to make a more efficient way of contacting emergency services. After testing our product in Pinellas County, we plan to launch nationwide. Now I'd like to briefly go over the product architecture of the Seat Sentinel. Here, you can see we're using a Raspberry Pi, as the Raspberry Pi is the most efficient and practical microcontroller for the Seat Sentinel. We also have GPS right here to let the Seat Sentinel know the child's location. We also have the cellular antenna for contacting the parent and emergency services, and here's the weight sensor to ensure that the child is in the car seat and to prevent false positives. And now to briefly summarize the design and functionality. The Seat Sentinel uses a weight sensor, temperature sensor, LTE, and GPS, and it interfaces with the car's data port for the car alarm using the auto manufacturer's API. It also includes innovative crash protection measures that earn ratings of 5 stars from the NHTSA. And it uses a mobile app that can display location and temperature data in real time. Finally, the app can push notifications that remind a parent to take his or her child out of the car, and the app can also calculate risk levels that determine which action is most appropriate. The app can finally automatically contact emergency services if the child's life is in jeopardy with the pertinent data. Some infrastructure and legal considerations include signing a 1 to 2 year exclusivity agreement with an auto manufacturer so we can use their API and have cooperative marketing and use their proprietary technology such as OnStar. We also want to sign a volume licensing agreement with a cell network so we can get our LTE service to customers at a low cost. We're forming an LLC so we can protect our personal assets in case of insolvency of the Seat Sentinel. We also wrote terms of service that limit our liability in case a flaw in the Seat Sentinel causes a tragedy and relieve us from liability if the Seat Sentinel functions properly and yet a child still dies of heat stroke. Finally, we're including warning labels that inform the consumer that although Seat Sentinel can reduce the risk of child heat stroke, it cannot eliminate it entirely. Now I'd like to reintroduce Nathan Hamilton, our software developer, to go over product testing.
While the design and function of a mobile application is pertinent, we also need to make sure that we test our application. So the first thing we need to do is to set up a hot car in an 85 to 95 degrees situation. Next, we would place a test dummy within the car. We would monitor when the car reached 85, 90, and 95 degrees respectively, and take appropriate action. Now, I'd like to reintroduce our project manager, William Klein, to discuss project timeline.
Thank you, Nathan. We began conceptualizing this project in September, and we conducted market surveys in October. We also hit a milestone on October 19th when we filed our provisional utility patent. In November, we worked on user interface and program logic, and in December, we began interfacing the Seat Sentinel's functionality within the Internet of Things. We plan to begin alpha testing in January, and we plan to sign our auto manufacturer exclusivity agreement and cell network volume licensing agreement in February, so that we may begin beta testing and conducting our product launch in March if all goes well. Now, just to go over how this project has gone so far, we've had a few challenges. Obtaining the automobile API and cell network service has been an ongoing challenge, as well as patching security vulnerabilities is something that we've been focusing on throughout our project. Navigating the patent process was difficult, but we did overcome that challenge. That said, this project has also had many successes. Interfacing the sensors with the Raspberry Pi went quite smoothly. We also conducted a market survey, and we're using that data to help improve our product. And we're also finalizing our program logic and UI as we speak. Just to discuss the project status and what we plan to do, we've already developed the structure of both the program logic and the sensor layout. We've filed a provisional utility patent, and we're ready to begin testing cell networking, although we still need to obtain the auto manufacturer's API. Finally, we'll soon begin contacting companies regarding the exclusivity agreement and cooperative marketing agreement with the auto manufacturer. And on behalf of the software developer Nathan Hamilton and the product designer Nassim Hamid, who unfortunately couldn't be here today, I'd like to thank you for joining us in helping parents keep their children safe.